Welcome to Python Basics. In this series, we will cover the fundamental building blocks of Python programming. Whether you are completely new to coding or switching from another language, this series is designed for you. Let us start with the most basic question. What is Python? Python is a general-purpose programming language. That means you can use it to build almost anything: websites, games, data tools, automation scripts, and much more. Python is designed to be simple, readable, and easy to learn. Even if you have never written a single line of code before, Python is one of the best languages to start with. Now, who uses Python? Software developers use Python to build applications and tools. Data scientists use it to analyze large amounts of data. Researchers and mathematicians use it for scientific computing. Network engineers use it to automate tasks. And students and beginners use it as their first programming language. So, what can you actually build with Python? You can build websites and web applications. You can analyze data and create charts. You can build artificial intelligence and machine learning models. You can write automation scripts to handle repetitive tasks. You can create desktop applications, mobile apps, games, and scientific research tools. Python is one of the most versatile languages in the world, and its popularity keeps growing every year. In the next part, we will look at why Python has become so popular. Now, let us look at why Python has become one of the most popular programming languages in the world. There are 5 main reasons. The first reason is that Python is easy to learn. Python's syntax looks like plain English. You do not need to memorize complex rules. Beginners can start writing real code very quickly. For example, to print something to the screen, you simply write print, open parenthesis, then your message in quotes, close parenthesis. That is it. The second reason is that Python requires less code. To solve the same problem, Python typically uses far fewer lines than languages like Java, C++, or C#. Less code means faster development and fewer places for bugs to hide. The third reason is Python's huge community. There are millions of Python developers around the world. This means there are tons of tutorials, libraries, frameworks, and forums where you can find help at any time. The fourth reason is powerful libraries. Python has thousands of ready-made libraries for almost every task: artificial intelligence, data analysis, image processing, web development, and much more. You do not have to build everything from scratch. The fifth reason is that Python is cross-platform. You write your code once, and it runs on Windows, Mac OS, and Linux without any changes. These 5 reasons together make Python one of the best choices for beginners and professionals alike. Now, let us look at some of the biggest companies in the world that use Python. This will show you that Python is not just for learning, it is used in production at massive scale. Google uses Python for its search engine, for TensorFlow, which is their machine learning framework, and for the YouTube backend. Instagram is built almost entirely on Python, using a web framework called Django. It handles hundreds of millions of users every day. Spotify uses Python for its data pipelines and its music recommendation algorithms, the system that suggests songs you might like. Amazon uses Python for backend services, data engineering, and artificial intelligence tools across its platform. Netflix uses Python for its recommendation engine and for data analysis, figuring out what shows to suggest to each viewer. And NASA uses Python for scientific research and space mission software. These are not small projects. These are systems used by billions of people every day, all powered in part by Python. Python is used everywhere, and now it is your turn to learn it. Let us get started. Before you can write Python code, you need to install Python on your computer. The good news is that Python is completely free. It works on Windows, Mac OS, and Linux. Let us go through 3 simple steps. Step 1 is to download Python. Go to the official Python website at python.org and download the latest Python version and then install it. Important note for Windows users only. During installation, you will see a checkbox that says Add Python to Path. Make sure you check this box before clicking Install. If you skip this, Python may not work from your terminal. Step 2 is to verify the installation. Open your terminal and type python-version. On macOS or Linux, you may need to type Python 3-version instead. You should see output like Python 3x. If you see that the installation worked. Step 3, you are ready. Open your terminal, type Python or Python 3 on macOS and Linux, and press Enter to start coding. Now, let us look at how to actually run Python code. There are two main ways. The first is the interactive shell. The second is a script file. Let us start with the interactive shell. Open your terminal and type Python, then press Enter. You can type any Python code and press Enter. Python runs it immediately and shows the result. The interactive shell is best for quick tests, learning, and experimenting. Now, let us look at script files. In script mode, you write your code in a file with a .py extension. For example, hello.py. Open any text editor, write your code, and save the file. Then go to your terminal and type Python, then the file name. Python runs the entire file. Script mode is best for real programs that you want to save and share. Here's a quick comparison. The interactive shell starts with a Python command and does not save your code. A script file starts with Python followed by the file name and saves all your code. Use the shell for quick experiments and script files for real projects. Now, let us look at one of the most important functions in Python, the print function. The print function is how you display output to the screen. The basic syntax is print in parentheses the value you want to show. Let us look at some examples. To print a string of text, write print in parentheses hello, world in double quotes. Python displays hello world. To print a number, write print in parentheses 42. No quotes needed for numbers. Python prints 42. To print multiple values, separate them with commas. Now, let us look at some useful options. The first is separator. By default, Python puts a space between multiple values. You can change this with sep. The second is end. By default, print adds a new line after the output. You can change this with end. For example, end equals a space in quotes will keep the next output on the same line. The third is the \n character. This is the new line character. You can put it inside a string to force a line break in the middle of your text. Key tip: print always adds a new line at the end by default. If you want to stay on the same line, use end equals two quotes with nothing between them. Now, let us talk about comments. A comment is a line in your code that Python completely ignores. It is only there for you, the programmer, to read. Comments are very important. They help you and others understand what your code is doing. There are two types of comments in Python: single-line comments and multi-line comments. To write a single-line comment, use the hash symbol. Everything after the hash on that line is a comment. Python will not run it. You can also add an inline comment at the end of a code line. For example, x equals 10, then space, hash symbol, then your comment. The code on the left runs, but the comment is ignored. One useful trick is commenting out code. Put a hash before a line of code, and Python will skip it. This is helpful when debugging and you want to temporarily disable a line. Now, let us look at multi-line comments. If you want a comment that spans many lines, use triple quotes, 3 single quote characters together. Put triple quotes at the start. Write your text across as many lines as you want, then close with another set of triple quotes. Python ignores everything in between. Triple quotes are also used for docstrings, documentation written at the start of a function to explain what it does. Why use comments? First, they explain what your code does. Second, you can use them to disable code while debugging. Third, they help teammates understand your code. A good rule: write comments for anything that is not obvious at first glance. Now, let us talk about variables. Variables are one of the most fundamental concepts in any programming language. A variable is a named container that stores a value in memory. Think of it like a labeled box. You give the box a name, put something inside it, and later refer to it by that name. To create a variable in Python, write the variable name, then an equals sign, then the value. The equals sign here means assignment. You're storing a value into the variable. Let us look at some examples. To store a number, write age equals 25. The variable called age now holds the value 25. To store text, write the text in quotes. For example, name equals Alice in quotes. The quotes tell Python this is a string of text. To store a true or false value, write is underscore student equals true. Notice that true starts with a capital T in Python. Variables can also be reassigned. You can change what value a variable holds at any time. For example, if you write x equals 10, then x equals 20 on the next line, x now holds 20. The old value is replaced. Now, let us look at naming rules. You must start the name with a letter or an underscore. You can then use letters, numbers, and underscores. You cannot start a variable name with a number. You cannot use spaces. Use underscores instead. And you cannot use Python keywords like if, for, or while as variable names. Look at the examples. My underscore name, underscore score, and user1 are all valid. But one name, my space name, and if are all invalid. One more tip. Python variable names are case sensitive. Now, let us explore dynamic typing, one of Python's most powerful and flexible features. In Python, you never have to declare what type of data a variable holds. Python figures it out automatically when your code runs. This is called dynamic typing. Let us compare this with other languages. In a statically typed language like Java or C++, you must declare the type before using a variable. For example, in Java, you would write int space age equals 25 semicolon. You are explicitly telling Java this variable holds an integer. In Python, you simply write age equals 25. That is it. Python sees the value 25 and automatically knows it is an integer. No declaration needed. This makes Python code shorter and much easier to write. Now here is something interesting. In Python, a variable's type can change at runtime. For example, write x equals 10. At this point, x holds an integer. Then on the next line, write x equals hello in double quote. Now x holds a string. Python does not complain. The type simply changes. This is what makes Python so flexible and beginner-friendly. Now, let us look at the id function. This is a built-in Python function that reveals something interesting about how Python stores data behind the scenes. Every value in Python is stored somewhere in your computer's memory, also called RAM. The id function returns the unique memory address of that value. Think of it like a house address, but for data in your computer. Let us see a basic example. Write x equals 42. Then write print in parenthesis id in parenthesis x. When you run this, Python prints a large number. That is the memory address where the value 42 is stored. Look at the memory diagram. The variable x is just a name. It does not hold the value 42 directly. Instead, it points to a location in RAM where 42 lives. The id function shows you that address. Now here is something interesting. What happens when two variables hold the same small value? Write a equals 10 and b equals 10. Then print the id of a and the id of b. You will see the same id for both. This is because Python caches small integers to save memory. For integers between -5 and 256, Python reuses the same object in memory rather than creating two separate copies. Both a and b point to the same memory location. This is a feature specific to CPython, which is the standard Python interpreter. Now, let us see what happens when you reassign a variable. Write x equals 10 and print the id. Then write x equals 99 and print the id again. The two IDs will be different. When you reassigned x to 99, Python created a brand new object in memory and pointed x to that new location. The key insight is this. In Python, variables are just labels pointing to objects in memory. The id function lets you see exactly where those objects live. Now, let us look at the input function. This is how you get information from the user while your program is running. When Python hits an input call, it pauses the program and displays a prompt message on the screen. The user types something and presses enter. Python captures what they typed, and your program continues. The basic syntax is variable name equals sign, then input, in parenthesis, your prompt message in quotes. Let us look at an example. Write name equals input in parenthesis enter name. Then write print hello comma name. When you run this, Python displays enter name and waits. If the user types Alice and presses enter, Python stores Alice in the name variable and print displays hello, Alice. Now here's the most important thing to know about input. It always returns a string, even if the user types a number. So if someone types 25, Python treats it as the text 25, not the number 25. You cannot do math with it directly. To fix this, you convert the input. Use the int function to convert to a whole number, or the float function to convert to a decimal number. In the next topic, we will cover multiple assignment and variable swapping. First, multiple assignment. The first form assigns the same value to several variables at once. Write x equals y equals z equals 0. Python reads this right to left and sets all three variables to 0. If you print x, y, and z, you get 0, 0, 0. This is great for initializing multiple counters at the start of a program. The second form assigns different values to different variables all on one line. Write a comma b comma c equals 10 comma 20 comma 30. Python pairs each name on the left with the matching value on the right. So a gets 10, b gets 20, and c gets 30. Now, let us talk about variable swapping. In most other languages like Java or C++, to swap two variables you need a temporary helper variable. You copy a into temp, copy b into a, then copy temp into b. That is 3 lines just to swap two values. In Python, you can do it in one single line. Write a comma b equals b comma a. That is it. Here is why this works. Python evaluates the entire right side first, capturing both values, and then assigns them to the left side in order. So a gets the old value of b, and b gets the old value of a. No temporary variable needed. This is one of the most elegant features of Python, and you will use it often when working with algorithms. Our final topic is naming conventions and best practices. This is about writing code that not only works, but is easy for others to read and maintain. Python has an official style guide, Python Enhancement Proposal, and number 8 defines how Python code should be formatted and named. Following it is a sign of a professional programmer. Let us start with naming styles. There are 4 common conventions in Python. The first is snake case, all lowercase letters with words separated by underscores. For example, user underscore name or calc underscore total. This is what you use for variables and functions. The second is Pascal case, also called upper camel case. Each word starts with a capital letter with no underscores. For example, bank account or my class. This is used for class names. The third is all caps with underscores like max underscore size or pi. This is used for constants, values that never change in your program. The fourth is a leading underscore like underscore helper or underscore count. This signals that something is private or internal, a hint to other developers not to use it directly from outside. Now, what makes a good name? A good name like user underscore age or is underscore valid tells you exactly what the variable holds. A bad name like x, temp, or foo tells you nothing. Always choose descriptive names. Here are 5 key rules to follow every day. Always indent with 4 spaces, never tabs. Put only 1 statement per line. Use descriptive, meaningful names. Put spaces around operators. Write x equals 1 plus 2, not without spaces. And group related lines of code together. Thank you so much for watching this tutorial. I hope you found this lesson helpful and easy to understand. If you enjoyed this video, please hit the like button. It really helps the channel grow. Don't forget to subscribe to the channel for more beginner-friendly programming tutorials and helpful tips. Feel free to comment your questions or thoughts below. I love hearing from you, and I try to respond to every comment. And don't forget to hit the bell icon so you get notified whenever I upload new videos. See you in the next lesson.